This is the first of two videos that will show you how to solve limiting reactant problems. Whether you are in a general chemistry class, organic chemistry class, or even biology or geology classes, you'll most likely utilize these steps to solve limiting reactant problems. Well, what is a limiting reactant problem? The definition of a limiting reactant is the substance that is totally consumed when a chemical reaction is complete. The limiting reactant will determine the amount of product formed because the reaction cannot proceed any further without it. In your workbook, I have listed a series of steps that you should follow to guide you in the process of solving a limiting reaction problem. Let's give a simple example. Well, first we need a chemical reaction. The reaction is one female plus one male equals one couple. Simple enough, where females and males are the reactants and the couples are the products. As a simple example, let's assume you have 20 males in the class. Then you would have 20 couples. But let's say you have 29 males and 25 females in the class. You can simply say that you will form 25 couples and will have 4 males left over. This second example is a limiting reactant problem because the number of females limit the number of couples that can be formed and the males are considered the excess. For my disclaimer, this is a simple example. Not all couples are males and females. I just want to put it out there. As simple as this reaction calculation is, you must follow my steps to solve the problems. Let's go over the steps. Step 1. If you have quantities of more than one reactant, it is a limiting reactant problem. You may proceed. You don't have to follow these steps if you don't have a limiting reactant problem. Well, what do you mean? In the first example, you only have 20 males to form 20 couples. Not a limiting reactant problem. In the second example, you have 29 males and 25 females. This is considered as a limiting reactant problem because you have quantities of more than one reactant. Now that we have a limiting reactant problem, we can proceed to step 2. Step 2, pick a product. Well, there's only one product, couples. Step 3, how much of that product will you form from each reactant? In this case, the conversion factor is 1 male equals 1 couple and 1 female equals 1 couple. So with 29 males, you form 29 couples. With 25 females, you would only form 25 couples. Step 4. The reactant that gives the least product is a limiting reactant. In this case, females is the limiting reactant, not the 25 couples. The male is the excess reactant. Step 5. Using that reactant, the females in this case, how much of the other product will you form? Well, there's only one product in this example, so we can skip this step. Step 6. Using that reactant, once again, the females, how much of the other reactant will you need? The conversion factor is 1 male equals 1 female, so you need 25 males. Step 7. Subtract the amount of excess needed from the amount that you started with. You started with 29 males, but only need 25 males. So therefore, you have 4 males left over. Step 8. I'm going to give you more information for step 8. If the class only formed 20 couples, what is the percent yield? The definition of percent yield is the actual yield over the theoretical yield times 100. The theoretical yield is what you calculated from the limiting reactant. The actual yield is what was actually produced in the laboratory. In this case, the theoretical yield is 25 couples, and the actual yield is 20 couples. So the percent yield is 80%. Step 9, consolidate your answers. I am not going to sort through your work to find the answer, so you must put your answers together. At the end of the reaction, you will have 4 males, 0 females, 25 couples, and the percent yield is 80%. If you follow these steps for all your limiting reaction problems, you will do well. And that is how you solve any limiting reaction problem.